So in section 2.6, we will find whether the function is even function or odd function. So once we have a function, the function can be an even function can be an odd function. Okay, now we'll talk in detail. So let me take a graph here. So we have this graph. Now at first, is this graph a function or not? What do you think? Is this graph a function or not?
Yes.
We draw vertical and it crosses once, right? So this is a function. What can we say about the domain for this function? What is the domain for this function? What domain means what x values this graph can have? Negative infinity, positive infinity. Okay, how can you say that?
I'm just going to go on forever.
Yes, so here we can extend. So we have an arrowhead on both sides. It means we can extend this graph all the way to the left and all the way to the right. Okay, and on the x-axis, on the left we have negative infinity, on the right we have positive infinity, right? So since we can extend this graph on both sides, the domain is from negative infinity to positive infinity. So when you are asked to find the domain, you find like how far you can extend your graph. Now what about the range? And when we talk about the range, we are looking for how far you can extend your graph up or down. That's what we are looking. Now what would be the range for this function? 0 to infinity. Okay, now if you extend both sides, we can't have the y values which is below x-axis, right? So we can't have negative y values, but we can have a number which is 0 or all the way to the positive infinity, and that is the range. So here our range is from 0 to positive infinity. Okay, so we're going to include 0 here. Now it doesn't look like it touches x-axis, but I'm trying. Okay, so here the graph touches x-axis. Okay, so here the graph touches. Okay, now this graph. Okay, let me draw one more graph. Now is this graph a function? No. Okay, now here, so if we okay, let's take this is a graph 1 and this is graph 2. So if we observe graph 1, what is y-axis doing to our graph 1? So we have y-axis. Okay, now here we have the y-axis, and the y-axis is dividing our graph exactly into two similar parts, right? Okay, similarly, so we have this graph and this graph. So here x-axis, this is the x-axis. Okay, x-axis divide this graph exactly into two similar parts. Okay, so let's focus on this graph. So here our y-axis divide this graph into exactly two parts. Okay, it means this is a function, right? And this means this function is symmetric with respect to y-axis. Okay, so here this graph is a function and this function is symmetric with respect to y-axis. Symmetric with respect to y-axis means your y-axis that divides the graph exactly into two similar identical parts. Okay, if your y-axis divides into two identical parts, then that is the symmetric with respect to y-axis. And similarly, if x-axis divides the graph exactly into two identical parts, then that is symmetric with respect to x-axis. Okay, now here, so the very first way is, if your graph, you have a graph and if the y-axis divide into two identical parts, it is a symmetric. And the other way to check whether the graph or a function is symmetric or not is if you have x as a domain for a function. Okay, we have a function has a domain, and if x is a domain for function f, and if the negative of that x is also a domain, then your function is symmetric to y-axis. If you have a graph, it's very easy. If you see the y-axis dividing into two equal parts, it is symmetric with respect to y-axis. But every time you may not have a graph. Okay, if you don't have a graph, then we're gonna use this second concept. And the second is that we have a x as a domain for a function. Okay, so we have x for a domain of a function, and for the same function, if negative of that x is also a domain, then our function is symmetric with respect to y-axis. Okay, so here, for example, so let's take a function. Let me take a function f of x equals x squared plus 1. So this is the function that we have. Okay, for this function, what is the domain here? What represents domain for this function? X, right? So x is the domain. Okay, now what we do, we replace x of this function by negative x. Okay, and if we get the same function, then our function is symmetric to y-axis. So we replace x by negative x. Okay, so we replace x by negative x. Now let's see what happens. If we get the same function, then yes, it's a symmetric. Okay, if we replace x by negative x, we have f of negative x equals to, our x is negative x, we have a square plus 1, and we have negative x square, that is x square plus 1. And what is this x square plus 1? X square plus 1 is f of x, right? So which is f of x. So after replacing x by negative x, we get the same function. It means this function x square plus 1 is symmetric with respect to y-axis. Okay, so for a function, if x and negative x is a domain, then your function is symmetric with respect to y-axis. And this kind of function are also called even functions. You have a graph, your graph is symmetric to y-axis. That means the graph is even function. Okay, you have a function, and if x and negative x is a domain for a function, then the function is even function. So every time if you are asked to check whether your function is even or not, you have to replace x by negative x. Okay, and after replacing x by negative x, if you get the same function, then it is a even function. If you get a different function, then it is not a even function. Okay, for example, let's do which is not even. For example, if we have something like f of x equals to x cubed. Now you replace x by negative x. So we have f of negative x equals to negative x cubed. And what is the cube of negative x? Negative x cubed, right? Now after replacing x by negative x, do we get the same function? We have a different function. We had x cubed. But after replacing x by negative x, we have a negative x cubed. These are a different function. It means this function is not even function. Okay, so to be a even function, you replace x by negative x in your function, and if you get the exactly same function, then your function is even function. This is one way. And other way to check is that you have a graph. If that graph is symmetric with respect to y-axis, then that is also an even function. Okay. Now the next we have an odd function. Okay, and here we do the same thing. We replace our x of our function by negative x. Okay, and after replacing your x of a function by negative x, if we get negative of the original function, so here f is missing. Okay, so you're gonna add f here. So after replacing x of a function, if you get negative of f of x, then your function is odd function. Okay, or your function is symmetric with respect to origin. Okay, now let me give you a function. So let's say we have a function. Let's consider we have a function f of x equals to x cubed. Okay. So here this is not an even function. Okay, this is not even function. Okay, now you replace x by negative x. You replace x by negative x. Now let's see what happens. We have f of negative x equals to negative x cubed. And what is the cube of negative x? That is negative x cubed, right? So we have negative as it is. And what is this x cube equals to? X cube is f of x, right? So we have negative of f of x. So when you replace x by negative x, if you get negative of the original function, then your function is odd function. And odd function is symmetric with respect to origin. Okay, so it means the function is same upside down or right on a right left side. Okay, so we have a function symmetric with respect to origin. Okay, and in order to check whether it's symmetric with respect to origin or not, you replace x by negative x. If you get the negative of the original function, then it's a symmetric with respect to origin. Okay, now we do have a different way to check whether it's symmetric with respect to origin or the odd. Okay, so right now, so if your graph, okay, if your graph is symmetric to y-axis, it is even function. Okay, if your graph is symmetric with respect to origin, then your graph is odd function. And we do the same method. You just need to replace x by negative x every time. If you are asked to check whether it's an even or odd function, so one step, very common step, you replace x by negative x. If you get the same function, your function is even. If you get the negative of original function, then your function is odd function. Okay, and sometimes the function may be neither even nor odd. Okay, so now let's see in the examples here, and we are asked to check whether the function is even, odd, or neither. Okay, now let's have a example A, and the step is same. You replace x by negative x. So we replace x by negative x, and for all these examples we do the same thing. Okay, so if you're asked to classify even, odd, or neither, you just replace x by negative x. Let's see what happens. So we have f of negative x equals to absolute value, your x is negative x plus 2. Now what is absolute value of negative x? Positive x, right? Plus 2. So our f, and what is, okay, now here, after replacing x by negative, so after replacing x by negative x, do we get the same function? So we have x plus 2, and now is x plus 2 and x absolute value of x plus 2 are same thing? It's the same thing, right? So we get the same function. It means this function is even function. Okay, this is same as absolute value of x plus 2, and which is f of x. Okay, now let's go to number B. So this is an even function. Now let's go to number B. So you do the same thing. You replace x by negative x. So we have g of negative x equals to negative x negative 4 square. Now are these two same thing? So we need to check whether negative x negative 4 square is same as x minus 4 square. Are these two same thing?
Yes.
We can check by expanding. Okay, so we can expand this. So here, so let's expand. So what is this x minus 4 square is? So this x minus 4 square is same as x minus 4 times x minus 4. Now we use the FOIL method. Okay, multiply the first term x times x, that is x square. You multiply the outside term x times negative 4, that is negative 4x. Okay, let me erase this for a while. Okay, next we have inside term negative 4 times x, negative 4x, negative 4 times negative 4, positive 16, and we have x square negative 8x plus 16. Okay, so this is our g of x. Now you replace x by negative x. You replace x by negative x. Let's see what happens. we have g of negative x equals to, so for this x we have negative x square negative 8 times negative x plus 16. So we have negative x square is positive x square, negative 8 times negative x, positive 8x plus 16. Now are these two same thing? So we have x square minus 8x plus 16, and we have x square plus 8x plus 16. These two are not same. Okay, so this is not a even function. Or what about odd? Is this odd function? So to be a odd function, it has to be have a exactly opposite sign. So this x has a positive, we have a positive x square, but it should be exactly opposite sign to be a odd. So this is neither even nor odd. Okay, so it's not even, it's not an odd function. Now let's go to number. Let me know if you have any question up to here. It's the same process. Okay, you just replace x by negative x. If you get the same function, it's an even. If you get the negative of the original function, it's an odd. And if you don't have both condition met, then it's neither. Okay, hopefully C is odd function. Let's see. So for number C, it's the same thing. You replace x by negative x. Replace x by negative x. Every time if you are asked to check whether it's an even or odd, you do the same thing. You replace x by negative x. So our h of negative x equals to negative, for x you're gonna have negative x to the power cube plus 3 times, for the x you're gonna have negative x. So we have negative, and the cube of negative x, that is negative x cube. Okay, positive 3 times negative x, that is negative 3x. So we have negative times negative x cube, positive x cube, and negative 3x. Now let's compare with our original function. Our original function h of x is negative x cube plus 3x. And if the terms has exactly opposite sign, then that is the odd function. Okay, like x cube has a negative, here we have a positive x cube, 3x is positive, we have negative 3 here, so we have a exactly opposite sign. So what we can do here is that we can factor out negative. Now if we factor out negative, what happens? X, we have a positive x cube, it changed into negative x cube, right? We have negative 3x, it is changed into positive 3x. And what is this? What is negative x cube plus 3x? That is our h of x, right? So that is our h of x. So we have negative h of x. So h of negative x is equals to negative of h of x. It means this function is odd function. The function is odd function. If we get exactly same thing, it's a even. If the sign is exactly opposite, okay, for every term, if the sign is exactly opposite, you can factor out negative, okay, and you can just your function is odd function. That's the easiest way. If you get the same function, it's a even. If the terms is exactly of negative sign, opposite sign, then they are the odd function. Okay, so even function means it's a symmetric with respect to y-axis. Okay, it means the graph is divided into exactly 2/2 by the y-axis. Okay, and if it's odd means the function is symmetric with respect to origin. Okay, now okay, let me see if we can do one more example here from our homework. Okay, this is for you. Can you classify this function, and the function is f of x equals x to the power 5 negative 2x. Now you classify this function as a odd, even, or neither.